everyone. This is Dr. P. Srilata, Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. In this session, I am going to discuss about chi-square distribution. So before going to start chi-square distribution, already we have discussed chi-square distribution method 1. Okay, so now we will discuss about test of hypothesis for small samples. So what is the meaning of small sample? So if n is less than 30, then we can say that is small sample. So actually there are three types of test of hypothesis for small samples. First one is T distribution, second one is F distribution, and third one is chi-square distribution. So in T distribution we have two methods. First one is T distribution for single mean, and second one is T distribution for difference of means. Okay, so to find the chi-square distribution, we have formula that is summation y minus ei whole square by ei. Okay, so this is the formula for chi-square distribution. To find the observed frequencies, we have three methods. So first one is expected frequency by using average of to find the expected frequency by using average of all observed frequencies. So second method is to find the expected frequencies by using binomial distribution and also by using Poisson distribution. Okay, so by binomial distribution or Poisson distribution. So next third method is to find the expected frequencies. We have a formula that is row total into column total divided by grand total. So that is the formula for third method. So first, our second method is method 2. So method 2 in chi-square distribution. So method 2 chi-square distribution is here. So to find the chi-square value, here we have a formula that is summation y minus ei whole square by ei. So here in method 2, we need to find the expected frequencies by using binomial distribution or by using Poisson distribution. Okay, so here we need to remember one more thing is, here we need to find the chi-square alpha at nu equal to n minus 1 degrees of freedom. Okay, so like that we have to follow our procedure. In our procedure, for our first step is null hypothesis, and our second step is alternative hypothesis, and our third step is level of significance, and our fourth step is test statistic, and our fifth step is conclusion. So in the conclusion, in chi-square distribution second method, that is chi-square, modulus of chi-square is less than chi-square alpha, we accept H naught. If modulus of chi-square is greater than chi-square alpha, we reject H naught. Okay, so problems. Our first problem is given below is the number of male births in 1000 families having 5 children. So male children is 0, 1, 2, 3, 4, 5. The number of families are 40, 300, 250, 200, 30, 180. Test whether the given data is consistent with the hypothesis that the binomial distribution holds. Binomial distribution holds if the chance of male birth is equal to female birth. So here we need to find the given data is consistent or not with the hypothesis that the binomial distribution. Here we have to use the binomial distribution. Okay, so the chance of male birth is equal to the female birth. So we have to check this one. So for that, so our method is here we have to use binomial distribution formula. So what is binomial distribution formula? We know that the binomial distribution formula is P of x equal to x, that is equal to NCX P power x Q power n minus x. Okay, so here x values are 0, 1, 2, 3 and so on n. Okay, so and coming to the expected frequency. So the expected frequency of the binomial expected frequency formula is actually n into P of x equal to x. So in binomial distribution, the expected frequency is n into what is p of x equal to x? P of x equal to x is ncx p power x q power n minus x. So that is the formula for the expected frequency. Okay. So coming to our question, the given below is the number of male births in 1000 families. So let us consider this is capital N value and having 5 children. So this is small n value. So here they have given that male births, that is 0, 1, 2, 3, 4, 5. So that's why small n is 5 and the x values are here 0, 1. The random variable consists of small x or capital X, that is equal to 0, 1, 2, 3, 4, 5. So number of families. So these are the frequencies here. So these are the frequencies. They have given that for 0 that is 40, for 1 that is 300, for 2 that is 250, for 3 that is 200, for 4 that is 30 and for 5 that is 180. Okay, so total here we have if you add all these values. Okay, so if you add all these values, that means 40 plus 300 plus 250 plus 200 plus 30 plus 180, we will get 1000. That means capital N equal to 1000. So that is nothing but sigma. So summation of F, if you add all these values, means these are all frequencies. So if you add all the frequencies, then we will get 1000. That is nothing but a capital N value. Capital N equal to summation F, that is 1000. Okay. So and also they have given that N equal to 5. So what is P? So what are the possibility for P? So P, we know that P is probability of success. That means P of E equal to number of exhaustive events divided by total number of events. So for children we have two possibility, either male or female. So we are finding for male. So that means that is one possibility is there out of two possibilities. Okay. So like that for Q also same for female. So out of two possibilities, one possibility is there. Otherwise we can find that is Q is nothing but 1 minus P, 1 minus 1 by 2. That from that we can find 1 by 2. Okay. So N is 1000, small n equal to 5, P is 1 by 2, Q is 1 by 2. Next, the expected frequency. The expected frequency EI equal to N into P of X equal to X. So N into P of X equal to X is, here we are using binomial distribution. In the question they have mentioned that we have to use binomial distribution. So by the binomial distribution, the formula is P of X equal to X, that is equal to NCX P power X Q power N minus X. So N into P of X equal to X, that is equal to capital N into P of X equal to X value is NCX P power X Q power N minus X. So now we need to find the expected frequencies. So we need to find the expected frequencies. Our first expected frequency is E naught, that is equal to N into. So what is the possibility? What are the possibilities are there for X? So X is nothing but random variable. In random variable we have 1, 2, 3, 4, 5, 6. Sorry, that means 0, 1, 2, 3, 4, 5. So those are the possibilities. 0, 1, 2, 3, 4, 5. Okay, so for that, first I am calculating for 0. So that means A not equal to N into P of X equal to 0. Here, small x value is 0. And we know that capital N is 1000 and small n is 5. P is 1 by 2 and Q is also 1 by 2. So substitute all these values in the given formula, the expected frequency formula. So EI equal to N into P of X equal to X, that is N into NCX P power X Q power N minus X according to our binomial distribution formula. So E not equal to N into P of X equal to 0. So that means here small x equal to 0. Now substitute all these values in the formula. After simplification we will get 31.25. So like that we need to find for E1. Okay, so that is N into P of X equal to 1. N into P of X equal to 1. So that means here small x equal to 1. So and substitute capital N value, small n value, P, Q and X value in the given formula. So after substituting and after simplification, we will get this one. Okay, so like that we need to substitute for E2, E3, and for E4, E5. So in E5, so n into p of x equal to 5, that means small x is 2 and capital N is here 1000, small n is 5, p is 1 by 2, q is 1 by 2. So substitute all these values in the expected frequency formula. So that is n into p of x equal to x. So that is equal to n into, according to binomial distribution formula, that is n into p of ncx p power x q power n minus x. Okay, so substitute all these values in the formula, you will get E5. So now, so these are all expected frequencies, right? E0, E1, E2, E3, E4, E5. So coming to our table, so first we need to write the OI values. OI values means the given frequencies. These are all given frequencies. 40, 300, 250, 230, 180. So OI values are the given frequencies 40, 300, 250, 230, 180. And the EI values are, so already we have calculated. So that is E0, E1, E2, E3, E4, E5. So now substitute all these values in the table, EI values. So this is nothing but E0, this is E1, E2, E3, E4, E5. So substitute all these values in the table. So then after that we need to find OI minus EI whole square. So OI minus, so OI means 40 minus EI. EI means 31.25. So OI minus EI whole square. That means 40 minus 31.25 whole square. So that is 76.5625. So next 300 minus 156.25 whole square. So that value is this one. That is 250 minus 312.5 whole square. So like that we need to find for up to 180 minus 31.25 whole square. So that value is this one. Okay, so next we need to find OI minus EI whole square by EI. So that means OI minus EI divided by EI. So that means that is 76.5625 divided by 31.25. So we will get 2.45. So next one is 20,664.0625 divided by 156.25. So after simplification, we will get 132.25. So like that. So up to we need to find last value, that is 22,126.5625 divided by 31.25. So 708.05. So sum all these values. Summation of all these values are 997.76. Okay, so that means we know that chi square equal to summation of y minus ei whole square by ei. So this is the formula. So this is the formula, already we have calculated this value, but this is not a way to find this chi-square distribution, right? So we have one procedure. So what is that procedure? So first of all, we need to write the null hypothesis. After that, we need to write alternative hypothesis, then level of significance alpha. From this we need to calculate chi-square alpha. Next, we need to calculate test statistic. So this is our formula. Here we need to write our formula, that is chi-square equal to summation y minus ei whole square by ei. Okay, so this is our formula. Here we have to write in the fourth step. So next one is conclusion. So what is the conclusion here? The conclusion is, if mod chi-square is less than chi-square alpha, we accept H naught. We accept our null hypothesis. So if chi-square, modulus of chi-square is greater than chi-square alpha, so we reject H naught. So this is our conclusion. So already we have find chi-square distribution, that is chi-square equal to summation y minus ei whole square by ei, that is equal to 997.76. So next we need to write the null hypothesis. Okay, so our first procedure, in our procedure, our first step is null hypothesis. So null hypothesis is nothing but H naught. So H naught equal to OI equal to EI. H naught is nothing but OI equal to EI. Here I am taking OI equal to EI. That means there is no significance difference between observed frequency and expected frequency. So next, alternative hypothesis. So this is quietly opposite to the null hypothesis. So alternative hypothesis is nothing but opposite to the null hypothesis. That is denoted by H1. Here I am taking Y not equal to EI because this is not opposite to the null hypothesis. That's why Y not equal to EI. Here I am taking that there is a difference between observed frequency and expected frequency. There is a significance difference between observed frequencies and expected frequencies. Okay, so next one is level of significance. So first, before that, here understand that null hypothesis and alternative hypothesis both are assumptions only. Our next topic is next step is level of significance. So here they have given that alpha value. So they have not given alpha value. Here I am assuming that alpha value is 5%, alpha equal to 5%, that means 0.05. So now we need to calculate chi-square alpha at nu equal to n-1 degrees of freedom. So chi-square 0.05 because alpha value is 0.05 at nu equal to, so what is n value? So what is n value? N value is here 5. N value is 5. So n value is 5. So 5 minus 1 degrees of freedom. So that means chi-square 0.05 at nu equal to 4 degrees of freedom is 9.488. Already we have we have seen how to take this value from the table. Okay, I have shown in the previous session. So all of you go through that session also. So I will give in the description. So chi-square 0.05 at nu equal to 4 degrees of freedom. So here in the chi-square distribution, the alpha values are like this. Okay, so these are the alpha values. So for example, here we have 0.05 alpha value, and these are the new values. For example, here we are having 4. So we need to take this value. We have to take this column and this row. So the value is this one. So that value is 9.488. So we have taken this value. So chi-square alpha value from the table. Okay. So next one is test statistic. So chi-square distribution formula is summation y minus ei whole square by ei. So that value is already we have calculated in the table, that is 997.76. 997.76. After that we need to take mod chi-square, that is 997.76. Next one is conclusion. Okay, so coming to the conclusion, chi-square modulus of chi-square is less than chi-square alpha or greater than chi-square alpha. So we need to check. Okay, so modulus of chi-square is 997.76 and chi-square alpha value is 9.488. So this is 9.488. So this is obviously greater than value. 997.76 is greater than 9.488. That means modulus of chi-square is greater than chi-square alpha. So if modulus of chi-square is greater than chi-square alpha, we reject our null hypothesis. What is our null hypothesis? Already we have taken here. What is our null hypothesis? Here in the null hypothesis, I am taking that there is no significance difference between observed frequency and expected frequency. So that statement is wrong statement. So then what is the answer here? There is a significance difference between observed frequency and the expected frequency. So that is the required solution. So next question is, fit a Poisson distribution to the following data and test the goodness of fit at 0.05 level. So here we are having x values 0, 1, 2, 3, 4, 5, 6, 7. So that means n equal to small n equal to 7. And the frequencies are, So that means F values are here 305, 366, 210, 80, 28, 9, 2, 1. So if you sum all these values, you will get a capital N value. Okay. So we will do. So here we have to use the Poisson distribution. Goodness of fitting or fitting a Poisson distribution, both are same. Okay. So fit a Poisson distribution means what is the formula here to find the expected frequencies? We have formula that is n into P of x equal to x. So, but what is Poisson distribution formula? According to Poisson distribution formula, P of x equal to x, that is equal to e power minus lambda, lambda power x by x factorial. So, coming to the expected frequency, the formula is n into e power minus lambda, lambda power x by x factorial. So, now we need to find lambda value. Lambda is nothing but mean or average. So, here they have given that x values and f values. Okay. So, here we are, now we are going to find the mean. So, we know that mean is nothing but summation fx by summation f. Okay. So, for that we are finding this table. Okay. So, here they have given that x values 0, 1, 2, 3, 4, 5, 6, 7 and also given frequencies 305, 366, 210, 80, 28, 9, 2, 1. So, now fx. So, fx is nothing but multiply 0 and 305. You will get 0. 1 into 366, that is 366. 2 into 210, that is 420. 3 into 80, that is 240. 4 into 28, 112. 5 into 9, that is 45. 6 into 2, 12. 7 into 1, 7. So, sum of all these values, we will get 1201. Summation of fx. Summation of fx is 1201. If you sum all these values, we will get that is 1000. Okay, so that is 1000. Now, so coming to our formula, mu equal to, so we know that a mean, so that is mean mu equal to summation fx by summation f. So that means 1201 divided by 1000. So from that we will get 1.201. So that is nothing but mean is nothing but lambda. So that's why lambda value is here 1.201. So what is the expected frequency formula here? A equal to n into P of x equal to x. That is n into by Poisson distribution, the formula is e power minus lambda, lambda power x by x factorial. So what are the x values here? Here x values are 0 to 7. X values are 0, 1, 2, 3, 4, 5, 6, 7. Okay, so we need to find the expected frequency for every value. Okay. So for that, E naught is, that is nothing but n into P of x equal to 0. So that is x equal to, small x equal to 0. So n into, what is P of x equal to x? E power minus lambda, lambda power x by x factorial. So e power minus lambda, lambda power x value is 0 by 0 factorial. So we know that capital N is 1000 and lambda is 1.201. So substitute the values and also x equal to 0, substitute the values in the formula. So we will get this one. Okay, so that is E naught. So first expected frequency. So next we need to find E1. So E1 is nothing but n into P of x equal to 1. So that means n into here small x equal to 1. N into e power minus lambda, lambda power 1 by 1 factorial because x equal to 1. So substitute n value, lambda value and x value in the formula. We will get this one. So like that we need to follow the same procedure. We can find E2, E3, E4, E5, E6, E7. Okay. So in the E7, this is our last value. N into P of x equal to 7. That means here small x equal to 7. And we know that n equal to 1000 and lambda equal to 1.201. So what is the Poisson distribution expected frequency formula? By Poisson distribution, n into P of x equal to x. That is equal to n into n e power minus lambda, lambda power x by x factorial. So now substitute these values, n value, lambda value and x value in the given formula. So after completion, after finding, after simplification, we will get 0.21. So now, so these are all, we need to find the table. So expected frequencies. So observed frequencies are given frequencies. So these are all OI values. Given frequencies are observed frequencies. That means those are all OI values. So now we need to write the OI values here. Okay. So these are our given frequencies. Given frequencies. Are given frequencies. Okay. So and expected frequencies. Already we have found. This is E0, E1, E2, E3, E4, E5, E6, E7. Okay. So these are all expected frequencies already we have found. So this is a E0, E1, E2, E3, E4, E5, E6, E7. Okay, substitute all these values in the table. So then we need to find Y minus EI whole square. That means 305 minus 300.89 whole square. We will get 16.89. 366 minus 361.37 whole square. We will get 21.43. 210 minus 217 whole square. 49. Okay, so like that 1 minus 0.21 whole square, we will get 0.62. So after that we need to find Y minus EI whole square by EI. So that means this one divided by this one. Okay, so Y minus EI whole square by EI means 16.289 divided by 300.89. We will get 0.05. 21.43 divided by 361.37. So we will get 0.05. So 49 divided by 217. 0.022. 0.22. So next is 0.62 divided by 0.21. We will get 2.95. So if you sum all these values, that means summation of all these values, summation of Y minus EI whole square by EI. So that is equal to summation of all these values equal to, we will get 5.58. Okay. So that is nothing but our chi-square. So chi-square equal to summation Y minus EI whole square by EI. So from that we will get 5.58. So but we need to follow the procedure. So what is our procedure? Step 1, we construct the null hypothesis. So null hypothesis is denoted with H0. And here I am taking Y equal to EI. So that means there is no significant difference between observed frequencies and expected frequencies. So next, alternative hypothesis. Opposite to the null hypothesis, and that is denoted with H1. Here I am taking Y not equal to EI. So quietly opposite to the null hypothesis, alternative hypothesis. So in the null hypothesis, I am taking Y equal to EI, but in the alternative hypothesis, we need to take Y not equal to EI. That means there is a significant difference between observed frequency and the expected frequency. Next step is the level of significance. So the level of significance, they have given that alpha value. So here alpha value is 0.05. Alpha value is 0.05. Then we need to calculate alpha value at nu equal to n minus 1 degrees of freedom. So for that alpha value is 0.05 at nu equal to n value is 7. N value is 7. 7 minus 1 degrees of freedom. So chi-square 0.05 at nu equal to 6 degrees of freedom. That value is not this one. So we need to take the value here. Okay. So let us consider that is that value is for example, that is 16.91, but this is wrong value. We need to take the correct value. So let us consider that value is some 16.919. Then that will be next. We need to follow our procedure, that is test statistic. The formula is chi-square equal to summation Y minus EI whole square by EI. So that is 5.58. We have calculated here that value. Okay. So, and the modulus of chi-square is 5.58. So coming to the conclusion, modulus of chi-square is less than chi-square alpha. So because if I take this chi-square value is 60.919, then chi-square alpha will be 5.58. So that means 5.558 is less than 16.919, no? So we accept null hypothesis. That means the given statement is correct statement. So what we have taken in the null hypothesis? In the null hypothesis, we have taken that y equal to ei. That means there is no significant difference between the observed frequency and the expected frequency. That statement is correct statement. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.